Hello everyone. In this video, we're going to be talking about assembly techniques. We've spent a lot of time going over how to document individual part designs, and most things aren't made out of individual parts. So we also need to be able to document how things get put together. So that's why we have this unit on threads, fasteners, and welding symbols, and the next one on working drawings. So in this one, we're going to take a look at how to document different assembly techniques. And we're not going to get into depth about everything, but it gives you some information about what you're looking at when you're reading drawings and maybe some things that you'll need to get to know better if you do use these techniques in industry while you're working beyond school. So when it comes to fasteners, as you probably already know, fasteners are different devices that we use to hold things together. So there are lots of different types of fasteners that can be used. As a designer, one of the things you need to consider is whether or not the things that you are fastening together are going to be parts that need to be repeatedly disassembled and assembled, or are they things that need to be assembled permanently? One of the fasteners that we have is bolts. Bolts typically work with nuts or something that they can be threaded into. So when we have the designation for the size and the types of bolts that we put into our designs, they are standard. So when we look at the threading information and all of the different details and the dimensions of bolts and other fasteners for that matter, they're classified by their type, and each type has a industry standard for all the dimensions for all of the fasteners. So you don't need to dimension everything in a fastener unless that's specifically what you are dimensioning. When it comes to creating your drawings for your designs, you just need to identify what type of bolt. So that would be identified by the diameter, the thread type, and the length of the bolt. So there are lots of different types of bolts. These different types of bolts can be used for various applications, just depending on what you are trying to accomplish. Machine screws are kind of similar to bolts. There are different types of heads, different types of applications where you might be using them to assemble things with the machine and cap screw, a set screw, typically used with a shaft and collar to hold things together. And then you might even have something like a thumb screw that doesn't even require a wrench at all. When it comes to the threading information, there are different types of threading information because we have different measurement systems. So when it comes to the imperial threads are threads that are going to be for the US system and then metric for the metric system. So it's important to know what the information means as you look through your threading information. When it comes to drawing threads, the threads are going to be shown in different ways. So you can get a detailed drawing shown as the thread actually looks. Those are a little bit more rare because they have more detail than what you normally need. More common thread drawings are going to be schematic or simplified. Schematic, the threads are represented by lines, and simplified just by a dashed line. When it comes to creating the detailed drawing, you're showing every dimension as is. With the schematic, you're spacing the lines as the threads are spaced depending on the thread information. And with the simplified, you're not really showing the thread, each individual thread, but you're just showing the depth of the thread as represented by the hidden lines. Nuts are typically used to thread onto bolts or machine screws. So these are used to put objects together, to hold them together. And it's important that you have the same thread on the nut as you do on the bolt, otherwise they won't fit. So there are also different types of nuts that have different uses, again, depending on the application and the amount of force applied. If you're working with a machine that's maybe going to be doing a lot of rattling or have a lot of motion to it, you might need to use something like a lock nut or a castle nut designed to make sure that that nut doesn't work its way loose. Washers are placed under the bolts of heads or nuts. They give you a larger surface to apply pressure with those fasteners, and they also just give us a stronger hold over that area. We can also use lock washers in place of a lock nut to prevent a vibration from causing your nut to get undone. Sheet metal screws are exactly what they sound like. They're for threading through holes to hold sheet metal parts together. They can also be used in plastic as well. They're usually self-tapping, so you don't need to pre-drill unless, I guess it depends on the size of screw that you're using, but you can typically just screw these right through the material and they will hold things together. They also do work for things that need to be assembled and disassembled. So you can remove sheet metal screws and then rethread them in place. A lag screw is another type of screw usually used for a lot of holding power in wood. Pins can be used to hold things in place like shafts and nuts. These are often used where we have some sort of shaft that maybe goes through a pulley or part of a drivetrain of some sort. Keys also are used to prevent slipping on shafts. So there are some different designs for keys as well that can hold shafts in place. Rivets are commonly used in plastic and wood, and they can be used to hold things together. There's a metal pin that goes through the middle of the rivet, and when that pin is pulled back, the bottom side of the rivet is squeezed in place. These are meant for permanent things. With the springs, springs can be shown as detailed, schematic, or simplified. So simplified doesn't really look like a spring at all. It's just a box with an X, and then it would have a note explaining the spring. Another type of assembly is welding. So welding is meant for permanent hold. So welding can be done on plastic. Typically, we think of it being done on metal. Basically, you're melting the materials together and probably adding some sort of a filler material to increase the strength. So when it comes to a welding symbol, it looks like an arrow, maybe like a bent arrow. It may have a flag on top. That's a field weld symbol, meaning that the welding is actually going to be done out in the field and not in a factory. And then the tail may include some additional information. So the top side of the welding symbol is going to have information for the opposite side of the arrow, and the bottom note is going to be for the arrow side. So if we look at the welding symbols, here's some examples of a fillet weld. You can see the fillet weld is given dimensions for that weld. So the fillet is identified by the symbol, and then the fractions are going to tell you how big that fillet should be. There are different types of welds. You don't need to know all these different types of welds, but I just want to show you what the welding symbols may look like, so that way if you come across these, you're able to read them or create them if you need to. So one of the things that you will find in AutoCAD is there are add-ins for AutoCAD. So if you're ever going to be creating designs that use weld symbols, you can create them by using an add-in with AutoCAD that makes it very easy to create weld symbols. So it's not like it's something you need to try to draw out using text boxes. That would be pretty time consuming. So there are add-ins that you can use for AutoCAD that make these welding symbols easier. You won't need to do these in any of your drawings, but I think it's important to know, so that's why I included them in this presentation. All right, that is it for this presentation. Good luck drawing, everybody.